G'day guys, we're going to start looking into applications of calculus, but before we can do that we need to define some terminology and get you guys used to using it. So two of the words that you're likely to see when we're dealing with things regarding calculus is the concept of a tangent and a concept of a normal. A tangent, different to the tan from trigonometry, tangent is a linear equation with the same gradient as a point on a curve. So I could pick any point along this parabola, make a mark, make an approximate, and I can do a calculation using dy dx, and I could get a value for that line. And then what I would do is I would be then finding the exact equation of a line with that exact gradient that passes through that exact point. And the idea behind the tangent, and obviously it's poorly illustrated by my graph drawing abilities on the Wacom, is that the only time the tangent touches the curve on a parabola especially is at that one point and nowhere else. So they just touch and skim off. All right. A normal though is perpendicular to the tangent. Can you guys remember what the word perpendicular means? Someone in the chat, give me what perpendicular means. Yeah, 90 degrees. It's at 90 degrees to another line. So what I've got here is, yep. I have this green line. So the blue line is your tangent. And the green line is your normal. Now, for something to intersect at 90 degrees, do you guys remember how you calculate the gradient of a perpendicular line? There's a rule that it must satisfy. A normal has a gradient that is exactly perpendicular. A tangent has the same gradient. All right, so the tangent has the exact gradient of that point on the line. A normal is perpendicular. But also, if you imagine that graph, and you imagine the graph kept going, what's going to happen when it gets down here? I mean, obviously it's a bad drawing because I can't draw, but eventually that graph would intersect again. All right. So what you're going to be asked sometimes is to find the equation of the tangent given a particular equation. And to do that, you need to find dy dx to get the gradient at a particular point. And then you need to be able to use your linear equation formula, which, by the way, hopefully you guys remember. So what to do tangents and normals, because we only know the gradient and a single point, then the equation that we are going to absolutely have to use is that point there. All right? That's the equation that we're going to have to use to determine our gradients and our normals, because we know exactly one point and we know the gradient at that point. Therefore, we can use that, expand that, rearrange it all, get where we need to go. All right, so what we're going to do is we're going to do a couple of practice questions, and then I'm going to send you on your way. So, first things first. Find need to zoom out a little bit. Let's go. F of x is equal to let's do a negative parabola. So let's do negative 3x squared plus 6x plus 9. All right. Oh, actually, no. Let's be a bit saucy and do a plus 8. All right. So we need to find the tangent equation of f of x at f of 2. So we need to find the tangent equation at f of x at negative, where f of x is negative 3x squared plus 6x plus 8 at f of 2. By the way, what is f of 2 going to become, guys? So we need to find out what f of 2 is actually equal to. 2 squared plus 6 plus 8. So 2 squared is 4, so that's minus 12, plus 12, plus 8. Hey presto, what do we have? We cancel some down. We have 2. F of 2 is 8, which means that our tangent equation will need to pass through the point 2, 8. Okay, with me so far? So, we now need to find, well, what is f dash 2? We need to find the gradient at 2. So we're going to therefore need to use calculus to find f of f dash x. So what is f dash x? It's negative 3x squared plus 6x plus 8. If I take the 2 from down the top, 2 times minus 3 is minus 6. And then take the 1 down, minus 1. So it's negative 6x plus 6. So I now have my derivative graph. So I have f dash x. So I need to find f dash 2. So f dash 2 is therefore equal to negative 6 times 2 plus 6, which is negative 6, because it's, yep. So that means we have a line where m is going to be equal to minus 6, and it passes through to 8. Get out our equation. Y minus y1 equals mx minus x1. We whack in what we've got, so that's y minus 8 equals negative 6, 2 minus, x minus 2. Expand the right-hand side. negative 6x plus 12. Add 8 to both sides, and we get the equation y equals negative 6x plus 20. So if you were to graph that, that's what your full working out would look like. So, take a wild guess what I'm going to ask you to do now. No, I'm going to ask you to find the normal. All right. So, it's the same equation. So, f of x is still the same. I want you to find the normal at f of 2. So, remember that a perpendicular line, two lines are perpendicular if that is true. So if the gradient of one equation and the gradient of a second equation are multiplied together and you get -1, then you suddenly have a perpendicular pair. Now, we know M1 because we've already done it down here. So all we need to do is find our equation. So that's negative 6 times M2 equals -1. So I'm now going to divide both sides by -6. M2 equals -1 on -6. What happens to -1 on -6? Well, negatives and the negatives become positive, so the gradient of that line is going to be positive 1 on 6. So now you know the point and you know the gradient of the line. So it's going to be y minus 8 equals 1 on 6 x minus 2. You're going to expand that bracket out. Y minus 8 equals x on 6 minus a third. And then you're going to add 8 to both sides. So y is going to equal x on 6 plus 7 2/3. So that's going to be 23 over 3. Yep. Because 8 is 24 over 3, so I'm adding 24 over 3 to both sides, so 24 minus 1 is 23. So I now have, so here is my tangent, and here is my normal. So let's visualize this using our CAS, because I find it helpful to review what these things look like on our CAS. There we go. Window capture properties. So here's our CAS. So what we're going to do is we're going to go graph and table. I'll clear all this out. We don't need it. So what we're going to do is we're going to put in our equation 3x squared plus 6x plus 8. Graph that. Nice sad face. Oh, boo-hoo. Sad face. All right, it's got a turning point there. Now, on our CAS, all right, what we can do is, I'll move this over just a little bit. So we have our equations down the bottom there. And remember, it's an f of 2. So what we can do is we go analysis, sketch, tangent at x equals 2. And what you'll notice down the bottom there, it says y equals minus 6x plus 20. Oh, gee, would you look at that? It's right underneath. That's what I got. I can then go analysis, sketch, normal, and then do the same thing at x equals 2. Enter, and it tells me it is that, which, if you remember what your fractions look like, 0.166666 is 1 over 6, and 7.666667 is 7 2/3. Oh, would you look at that? All right. So we've just double checked our answers, proved that they're right. And obviously you can't see it on this, that they're 90 degrees, but they actually are. It's just how the way the CAS works is it's rectangular, not square. If it was all square, it would be nice and pretty. Oh, that looks a little bit more square. But the point stands. All right. Any questions before I finish the recording?